Hi everyone. I added some examples to this lesson and I have to do them. I want to do them for you. Before I uh, go to those examples, I would like to mention something here. This was part of the lesson, so I didn't change it, but I have to really mention this. When I have integral of 1 over x dx, I know it's ln x plus c because derivative of ln x is 1 over x. But I know ln is just defined for positive numbers, not zero, not negative. So here, if I want to be mathematically correct, I have to add an absolute value because I have to mention that although I don't know what is x, but I have to consider just positive values. Otherwise, ln is not defining those values. This wasn't part of the lesson, and I mean part of the notes, and I didn't want to change it. But if you want to be correct, you have to add absolute value. If you check Wiley plus also just accepts absolute value for ln. So if your answer for integral, if the answer is ln, make sure use absolute value, or make sure that the thing that you put inside ln is for sure positive. If it's for sure positive, you don't need to use absolute value. For example, if it is x squared plus 1, so that's a positive thing. So if it is x squared, so it's positive. So you don't need to um, put absolute value because it's positive. But if it's not, you have to add absolute value. So that's important here. Okay. Now I go to those examples that I added. Before I do those examples, I would like to repeat these. See, if I have integral, this is the most important one, number 4, integral x power n, it's x power 1 more n plus 1 divided by n plus 1 plus c. Don't forget c, otherwise I have to reduce mark. If you have a number multipled, you can bring that number out, like here. If you have plus minus, like 10, you can just say integral number 1, integral number 2. You can separate them. But you don't separate them for multiplication. No, 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 no. It doesn't work for these. For these, it doesn't work. Okay? Integral of e power x is just e power x plus c, and I talked about ln. Okay, so we know all of these rules, and we want to use them to do examples. Okay, I added these as examples here. Look at this. I have a number beside. Okay, remember, if it is coefficient and a number, I can bring it out, 4 over 3. And integral x power 1 over 3 dx, which is 4 over 3 x power 1 over 3 plus 1 divided by 1 over 3 plus 1, which is 4 over 3 x power 1 over 3 plus 3 over 3, which is 4 over 3 divided by 4 over 3 plus c, which is 4 over 3 x power 4 over 3 times 3 over 4 plus c. I can cancel this and this. I can cancel this and this. Or even from there, I can say I can cancel these two numbers. And the answer is x power this plus c. How do you show? If I say I don't want to see fractional exponent, you do this. Okay? Don't forget c. Also, if you have several integral, just add one c. You don't need several c. How about here? Here, this is division. And I know integral doesn't go over division, so I cannot say integral top divided by integral bottom. No. I have one thing in the denominator, which is monomial. So I can divide one by one. So integral w squared divided by w dw plus integral 29 divided by w dw. Remember, when I add, so one more symbol of integral, I need to add dw as well. It is w dw plus 29 comes out, and this is integral dw over w, which is w squared over 2. I know I have this formula here. I can add integral x power n dx is x power n plus 1 divided by n plus 1 plus c. Okay, so I can do that. Plus 29, that's ln. Okay, so that's ln. 29 ln, oops, what's happened? Okay, 29 ln absolute value w plus c. I told you. Wiley plus shows a correct answer. So the lesson didn't have absolute value because maybe they consider it's for sure positive. But mathematically it's wrong. Mathematically, when I say integral of 1 dx over x, I don't know what is the sign of x. So I have to say ln absolute value of x. In order to say, I need positive inside ln. Ln is not defined for negative. Okay, so Wiley plus accepts absolute value. Okay, how about here? This is this. Oh, I don't know radical, but I know it's integral x power 1 over 2 dx, which is x power 1 over 2 plus 1 divided 1 over 2 plus 1 plus c, which is x power 3 over 2 divided by 3 over 2, which is plus c, which is x power, so it's 2 over 3 this. So it's 2 over 3 radical this one plus c. Okay? How about here? What happened to 5 over 2? I can bring 5 over 2 out. Remember, I can bring the number out. Okay, so it's 5 over 2 integral dx over x. What's that? It's ln. But I told you, do it ln absolute value of x plus c. Because this is the correct formula. And Wiley plus does the correct formula. So if I have ln, because ln is just defined for positive, I have to use absolute value. I'm not sure if I have more examples here because when I add the other lesson, so I can see more examples because here just easy. And for the next lesson, which is the hardest part in integral, I can see more examples. Okay, so now I can go here, I can insert, I can go here, I can add topic to topic 30. For topic 30, I really want you to listen step by step. I do a step by step, so you listen. If you have question, ask me. If you have question, email me. Send a picture of a question, and I can do it for you. So, rules for finding integrals. Look at this question. Oops. What happened? Okay. What is this integral? You say it's integral radical. And I already did radical. Where is it? It's here. So I did yeah, it's here. Okay, look at this. This is the answer. Okay, for that. Okay, so radical. Yes, this is the answer. But here I don't have radical. Here I have just radical. I have radical. What's wrong here? Let me see. It doesn't work. I don't know what happened to the lesson. Okay, maybe I can finish this and then try again. Let me see if it's coming back. No. No, it doesn't work. Okay, so I can try after this again.